Continuing, sorry with that glitch, but reactions of carboxylic acids, yes, I wanted to put it alone. There are only two, so easy. Like number one is esterification, which here we can just put our, we can just put our, we can put our benzoic acid. Let me put it in a nicer way, There's another way to put your benzene ring. There's one way to do it like this, then flat, then down. Or you can put the flat line up, then you do this, then you do this, then you come back, and then put it like that. Then we can put our C double bond O, then OH, right? Okay, so here I could put it like this and like that. Still fine. Now, what happens is in esterification, it's going to meet an ester. It's going to meet an alcohol, rather, sorry. And you'll be just having your alcohol like a CH3OH, which is methanol. Then I'm going to get an ester. So I'll put the arrow here, but it's like, this is the arrow, okay? Well, what do we get now? Basically, the carboxylic acid is going to give the H and the alcohol gives the OH, okay? Although sometimes you say alcohol behaves as a weak acid, yeah, I know that. So you'd be like, well, isn't it the one that gives the H, whatever? But usually just work with the H coming from the carboxylic acid and the OH from alcohol. So you just have it like this and like that, go down, and then like this, then like this now. Then this becomes your C double bond O, and you still have this O now remaining. But what happens is this CH3 comes and joins itself. So it'll be O, then CH3. And here is your ester. This becomes your ester. And here is your... Now, how do I name the ester? Of course, you come here. This was benzoic acid, right? This was benzoic acid. And here, this was methanol. Okay, so when you do the ester, of course, the first part comes from the alcohol side, which is the side with no double bond O. This other side of the oxygen with no. You look at the oxygen, this side with the double bond O is the last part. Okay, this side with no, it comes first. So it's going to be methyl. Okay, it's going to be methyl benzoate. Like this. Okay, how easy is this? Now, this is just one. You can do any carboxylic acid, basically, even if you have one which says CH3, then COOH. And it is meeting a CH3, CH2OH. Basically, what happens? OH goes, H goes, and you end up having, again, CH3COO. We know that this will be a double bond, then the other one is just a single bond, which then goes to form a bond with the CH3CH2, but it's CH2 then CH3, okay? Because it bonds with this carbon with two hydrogens, right? That's what happens. And you would be done. Basically, that is what you have, okay? In esterification, it's easy, but remember to put here for your esterification on your arrow. Remember, on the arrow, say HCl and say heat, okay? Put your acid and heat it, okay? Now, the last reaction, which is the second reaction for carboxylic acid, only two to know. It is the reaction with the base, okay? We've seen, so you can say carboxylic acid plus base. For base, remember, bases are your hydroxides, which is like KOH or NaOH, strong base, okay? What are we going to have? Now, this NaOH, we've talked about him a bit. We've talked about him with alcohol. We've talked about him with something that had a chlorine, okay? And especially the ones that we talked about where if you have your benzene ring like this, and you're going to have a chlorine on it, okay? You remember this or you don't? And we call this our haloarine. And when we added NaOH, okay, when we added NaOH, we know what always happens. Whenever you add NaOH, you are going to get an alkoxide, okay? So, but for this one, we had temperature, we had to put it to like 623 kelvins and 300 atmospheres of pressure. And we will still get our alkoxide in the first thing. So the reaction always yields your alkoxide, which is just going to be O minus Na plus, okay? So this chlorine will go all together, then this Na and O will go here as an O minus Na plus. This H and chlorine will go, and they'll come back in the step 2 now to then convert this same thing to an alcohol, okay? Because what then happens is this Na will then see the CO and be like, I love group 7, and it's going to go away. Then you end up having an OH, and that is how we made our phenol, and you end up having NaCl. So this is what happens, okay? This is what happens. And the other time we saw NaOH, I'm just putting the times that you saw NaOH, was when you had something again like this with a benzene ring, and this time it is now your alcohol, right? Then what do? You add NaOH. Then what is it going to give you? An alkoxide. As simple as that. Okay, what does it do? Well, what just happens is you have it like that. We said in the OH, the H will go and the Na will come, and you have O minus Na plus, and then this H means OH and it will become an H2O. That is what happens. Okay, NaOH can literally meet any alcohol. For this one where it was meeting, we saw NaOH again meeting something with Br, but this time it does not make an alkoxide. Please, you don't need to put a temperature. What just happens is Br, since it's group 7, will jump to Na, and you have an OH, something with an OH. This happens for straight chain alkyl halides, okay? Then this Na and Br will go, then the OH will come here, okay? This is different from here, where you make an alkoxide, okay? It is different. Remember that for your alkyl halides that are basic, remember that they behave differently. Remember that. Don't forget. Okay, because in here you now have an OH, then this will be an NaBr. But we don't want this guy. We don't want him. We want to focus on here where we are making alkoxide. We saw that you always make an alkoxide, but here the alkoxide will then react with the hydrochloric acid and go to an alcohol. But obviously you're going to make an alkoxide. And that is the same thing again when you are going to have it meet your carboxylic acid. That's the reason we are talking about it in carboxylic acid. We'll still make an alkoxide. Here it's a phenoxide, okay? We are still going to make but this time it won't be a phenoxide. It will be an alkoxide. Just your O minus Na plus doesn't go away, okay? That is what happens with your acid and your base. You should know that, okay? It happens as well with your alcohol like that, okay? It happens as well with your alcohol. Don't limit it to just Na and NaH. You can have it like this again. This, we know that this H will come and join this OH, and then you have it as, you always have it as an alkoxide, O minus Na plus. But then you'll be having H and OH, which becomes H2O, okay? That is what happened. So now I'm going to erase the places where we have seen already, where you are going to get your NaOH. We have seen it where? Here, where you have a benzene ring and a chlorine, the haloarine. Here, a pheno. We've seen what happens. But now, and remember these temperatures, don't forget them. But now we want to see, our interest is what happens when we have carboxylic acid metered. We will still make an alkoxide, okay? We'll still make an alkoxide. Just remember that NaOH leads to an alkoxide, except when you're dealing with these, your alkyl halides. Okay, so here we'll be having everything. Let's put it. What do you have? You can just put any carboxylic acid that you want, okay? Let's put any carboxylic acid that we wanted. CH3COOH. Plus, here we can put our KOH or NaOH. Then what you're going to get is just going to be CH3COO minus K plus, okay? K plus H2O. This is all you're going to get, okay? How easy is this? Your alkoxide. This is going to be the alkoxide. Okay, and it's very, very easy, right? So that is what happens when you're in the reaction number 2, where you have benzene plus base, okay? All right. So this is what happens, and you'll be having your alkoxide. And you can do the same thing again. You can have it even if it was not just this is, what am I saying? This is benzoic acid. Benzoic acid. We're dealing carboxylic acid. Benzoic acid or any carboxylic acid, just say carboxylic acid plus base. Okay, you're going to get an alkoxide. So this is what happens when you add your NaOH or your KOH. You must get an alkoxide or a phenoxide, or something is wrong. You must get an alkoxide for your carboxylic acid. So if we put our benzoic acid, which we were just looking at, here's our benzoic acid. This is going to be COOH, okay? And now what happens here is if you add NaOH, then we are just going to get, what are we going to get? If we add NaOH, an alkoxide. Where? Here. So it's going to be like, the double bond is not touched, okay? and it's going to be like this, like this. Then here we have it like that, like that, like that, and it's going to be C double bond O. Then here is going to be O minus Na plus, and that's what happens. Look at how easy it is. This is easy, right? Yes, that's what happens, and these are all the reactions of carboxylic acids you have to remember. You have to remember this, okay? I know you can do it. I know you can do it. Remember for toluene, okay? And do you remember how we make it? And remember how when we make it, we saw how we add to your benzene, you add your CH3Cl and AlCl3. Okay, so whatever, this is what happens, and you'd be done. Goodbye for now. See you in the next one.